It turns out that whenever you want to do good measurements of these things, we know how difficult it is. And you found that out too.
Right.
And yeah, so just sort of remind me how it went. We started the impedance tube. Did you build one?
We built one, yeah. And I think the initial thought was, well, I was still trying to think of how to do the measurements in situ in 3 dimensions.
Yes.
People were using 2 microphones, and there's problems with that because there's mismatch in the microphones, and they see a different image and they get different reflections and all that kind of thing. And so I think some of those little details, particularly low frequencies, make a big difference. So I was thinking of things like using MLS measurements as a better approach. And also, if you remember, there was the microflone transducer, which was a dual micro hot wire anemometer for measuring acoustical particle velocity directly, so that you wouldn't have to use 2 microphones instead of trying to infer the reflection from looking at 2 different points in space. You'd look at the same point but look at velocity and pressure. So thinking of things like that. But when it turned out that the measurements in the tube weren't very good, just started looking at ways of improving the low frequency measurements of acoustical materials using a tube. And the whole idea between tube is you have a one-dimensional field. The funny thing was, when we did the work and decided how to build the tube and how long it should be and where the microphone ports should be and the diameter and so on to get the best results. And the interesting thing was, because in the old days there were big standing wave tubes, and you would have to, before you had digital and you could use a noise signal or an MLS signal, you would have to have a probe microphone that would go down the middle of the tube, and you'd find the maxima and the minima, and you measure the distances between and the amplitudes and so on. And Brüel and Kerr had a big old standing wave tube system, and I think maybe there was one at the university, and it had a 4-inch diameter pipe.
No, we didn't have it. Maybe it was in engineering.
It might have been. And then there was an 1.25 inch diameter, and so you'd have to test 2 of each, and it was very laborious, and you could only do it at discrete frequencies. And so when we were making the tube to do a noise signal, we worked out what would be best to get the widest useful possible range without having to test in 2 tubes and the microphone port distances and so on, and designed it and built it to do the research work. And then just about a couple months after that, the Brüel and Kerr salesman came around and said, "We've got a new impedance tube," and he pulled out his brochure, and it was exactly the same diameter and size and length and the microphone ports and everything. So that was kind of funny.